Alright, here we go. Module 1 study guide. Number 1 says, use the figure below to find the measure of angle CFE. So if I look at that angle, we have C, go to F, and then trace to E. So CFE are these two angles together. So when I look at what this diagram gives us, I see it gives me a right angle, and it gives me an angle that is 55 degrees. The right angle is made up of perpendicular lines. So knowing that, I know the other side of the perpendicular lines is also 90. So I know this angle is 90 degrees. Then I also see intersecting lines. Intersecting lines create vertical angles. So because I know angle AFB is 55 degrees, the vertical of that is angle DFE. So I know this angle is also 55 degrees because they are equal. So then finding the angle CFE, all I have to do is take the 90 degrees and add the 55 degrees to it. So angle CFE, is 145 degrees. Number 2 says classify each figure below as a regular or irregular polygon. Quick review. Regular polygons have the same angles and same side lengths. Whereas irregular polygons have different angles and or one or the other or both different side lengths. So that's the difference between those two types of polygons. So when I start, I'm going to just number them, and this is how I will put them in the boxes. You can do it however you want to. If you drew lines, that works. As long as you understand your study guide, we're good. So the number 1, that rectangle, they do have some of the same side lengths, but they're not all the same. So that would be irregular. Second one, you can see for sure that they definitely have different side lengths. So that one is also irregular. On 3, I can see these two are the same, but I can for sure see the difference there. That one is also irregular. On 4, this is a pentagon. All the angles are the same and all the side lengths, so that would be regular. 5, you can see all the angles are the same and side lengths, so that would also be regular. And then the same thing on 6. All the angles and side lengths are the same. So we kind of already answered number 3. It says, what makes a polygon a regular polygon? Again, they have to have the same angle measures and the same side lengths. All right, number 4 says state if there's sufficient or insufficient conditions to show the triangles are identical, which means is there enough or not enough? What is based here? So if I look at this first triangle, I can see there are 2 sides and an angle. And the angle is made up from the 2 sides, so this would be a side, angle, side. If I look at the one right beside it, it also would be a side, angle, side. So because of this, They are the same. It just looks like maybe they rotated it. So they took this one and they just flipped it over just a little bit. That would mean there is enough information to prove the triangles are identical. And then it says explain your reasoning. On this part, you could state both triangles are side triangles with the same notations. Make sure you include both of those. It shows you state what kind of triangle you have and that the notations are the same. Because it could be the same kind of triangle with different notations. If that were the case, the information would not be, so it would be insufficient. So it has to be the same triangle with the same notations. Number 5, state if there's sufficient or insufficient conditions to show the triangles are identical. So if I'm looking here, I can see triangle ABC gives me 3 angle measures, and that's it. So this would be an angle, angle, angle. And then DEF also gives me 3 angle measures, so it's also angle, angle, angle. Now, on this one, they do have the same kind of triangle, and they have the same notations, but there's something important missing with this kind of triangle. With angle, 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 it's not going to be identical because we don't know any of the side lengths. So because there's no side lengths, there's not enough information to prove it. So that would be your explanation as well. Explain your reasoning. There are no side lengths given. All right. Number 6. A right triangle ABC so that AB is 4 centimeters, BC is 5 centimeters, CA is 6 centimeters, and it says the measure of angle B is 90 degrees. We have to figure out if these conditions make one unique triangle, no triangle at all, or more than one triangle. So when doing this, we see we have a side, and a side, and an angle. So looking at this, we see that we need to follow the side, side rule. So our side, side rule, again, is the 2 smallest have to add to be greater than the longest. So my 2 smallest, 4 plus 5, we know that equals 9. Is 9 greater than 6? In this case, it is yes. So this would create a side, side, which we know is one unique triangle. On 7, it says a right triangle, DEF, so that DE is 3 centimeters, EF is 8 centimeters, and FD is 12 centimeters. And the measure of angle D is 70, that should be degrees. So again, I follow the side, side rule. So 3 plus 8 is 11. Is 11 greater than 12? That is no, so this would be no triangle at all. All right, I'm going to take some time for you just to look over those and think about those for a second. All right, number 8, it says, which of the following shapes could be a slice of a right rectangular prism. When we think of a right rectangular prism, we know there's 6 sides. So, a right rectangular prism, we could have a slice of a square. We could also have a triangle. We could also have a trapezoid. And we could also have a pentagon, because a right rectangular prism has 6 sides. So we could have a cross section of up to 6 sides. Alright, which of the following shapes could not be a regular polygon? The key word here is not. And a regular polygon, remember, has to have the same angles and same side lengths. Select all that apply. A hexagon would be a regular polygon. We're looking for the one that is not. A rectangle has 2 different side lengths, so that would be a not. A pentagon has 5 side lengths, so that would be, so I'm not going to select it. And then D, a scalene triangle, 2 sides would be the same, but the other would not, so those are the 2 you should have selected. 10, are these triangles identical? Explain your answer. So I can see my side lengths. I have 2 of the same side lengths, but I need at least 3 things to help this. So this is where we've looked at our intersecting lines, which create vertical angles, so I could add angles in. So knowing this, I now have side, angle, side, which your answer would be yes. These are the same. So they are identical. 11. What shape is formed by the region where the plane and the cube intersect? So that, where the plane and the cube intersect, is your cross section. So if I'm looking at mine, I know yours was not in color, but mine is green, and the plane is the green thing slicing the cube diagonally. So where it's crossing your shape is where it is a dark green. So on yours, it's like a darker gray. So that would be a rectangle. On 12, it says draw a shape that is a quadrilateral. Quadrilateral means 4-sided shape that has one side 3 times longer than the others. So the way that I set this up, I'm going to draw just a line, and then I'm going to do one on top of it that's about 3 times as long, maybe a little bit further. And then from there, I'm just going to connect those 2 lines. Your shape could definitely look different. The only stipulation here is it has to have 4 sides, and one of the sides has to be 3 times the length of the other. All right, on 13, it says draw 4 regular polygons. Guys, you have notes on this. I gave you a list of all these regular polygons. You could just start drawing them. They don't have to be perfect, because I know I am not a perfect drawer. Oh, that one's already really bad. Now, from drawings, obviously you can tell these are not all the same side lengths. So something I could do to help show that they are regular, I could add in my notations. And that just shows whoever's looking at this that all these shapes have the same side lengths and they have the same angle measures. 14, what shape is formed by the region where the plane and the pyramid intersect? If you look at the plane, it is slicing the pyramid parallel to the base, which means the cross section, which it shows it here, is in green. I'll go ahead and use this green too. It shows the cross section is in green, and that is a square. All right, 15. Which equation could be used to calculate x? Sorry, this picture looks a little funny. It kind of cut off the line that should be there, okay? So this angle is 3x plus 50. This angle is the 90, and then this little angle is x degrees. So looking here, it says that 3x plus 50 equals 90. So it's stating this angle by itself equals 90. You can tell from the perpendicular lines that would not be true. The next one says x plus 3x plus 50 equals 180. So that means this angle and this angle by themselves equal 180, which is a straight line. In that case, this one is also not true. For C, it says x plus 3x plus 50 equals 90. So if we think about this, they are not right beside each other. They are part of a 180. But if we think about intersecting lines also, this x degrees would be the same over on the other side as well because they're vertical angles. And then if I think about that right angle from the perpendicular lines, the other side would also be a right angle. So if I read C again, it says the x angle plus the 3x plus 50 equals 90 degrees. So that one would be my correct equation, and it is complementary. All right, 16. Again, this kind of cut through the lines a little bit. I'll just fill them in. Alright, so looking at this, I have intersecting lines. And we know that intersecting lines create right angles. So when setting this up, these two angles would be equal to each other. So to write my equation, I would have 5x equals 2x plus 36. We have done multiple examples of this. My suggestion was moving the smaller x value from one side to the other on both sides of the equation to keep it balanced. So I would subtract 2x from both sides. So on the left side, I have 5 x's, and if I take out 2 of those x's, I have 3 x's left. On the right side, if I have 2 x's and I subtract 2 x's out of it, those cancel. I don't have any more x's, and I bring down 36. So then my last step to isolate the variable using inverse operations is dividing each side by 3, and x equals 12. Now this question says, what's the measure of angle DCE? It does not ask for us to solve for x. We have to figure out the angle, but I now need to solve for that side. So I have to take the 2x plus 36, and I need to plug in what I know about x now. So when I calculate all of that, I end up with angle DCE equaling 60 degrees. All right, then number 17, this is our last problem. All right, it says if measure of angle BGC is 3x. Let me find BCG. It is this yellow angle. It tells me it is 3x degrees. And the measure of angle AGF is 5x minus 3.6. So I'll do that angle AGF is right here. Do this one blue. And I'll add in the 5x minus 3.6. And the question says, what's the measure of angle EGF? So EGF is right here. So that is what I'm looking for, but it tells me nothing about this angle, so I'll just put my question mark there. All right. Something I can think about here are, again, vertical angles. There's so many different ways of solving this problem. I don't care which way you use. For me personally, I would understand that this side is also a 90 degrees because of this right angle that's given. And I would use angles on a line. So I would have 5x minus 3.6 plus 90 plus 3x equals 180 degrees. Before I start solving, I am going to combine like terms. So I would end up with 8x, and I would do 90 minus 3.6 to get 86.4 equals 180. From here, I just start solving. I would subtract 86.4 from both sides. So leaves me with 8x equals 93.6. And I'm going to divide by 8 on both sides, which gets me 11.7. Now, even though I solved for x, I am not done, because I now need to solve for that red angle, the EGF. Again, I can think about vertical angles. The yellow angle, BGC, is 3x. It is vertical to the red one, EGF. So I know that angle EGF equals 3x. So to solve for that angle, I plug in what I know about x. And angle EGF is going to equal 35.1 degrees. All right, we are done with our study guide. Please review this and practice these problems as much as possible.